mechanical engineer who looks after the all the maintenance activities of the rolling stock which are happening in that zone. We will also find PCMEs in the production units. So there is a principal chief mechanical engineer here at Raebareli in Integral Coach Factory in MCF and RCF who are looking after the manufacturing activities of the components in that units. More details on coordination of MNP program. Yes, in foundation, you just understand that MNP is purchased by different users. So engineering department may be needing some MNP. For example, they may be needing an overhead crane. So how they are going to purchase that overhead crane, how will railways sanction that is all is followed under the program called MNP program. And MNP program in detail as a subject is taught in induction. So I'll cover this in induction. As of now, during foundation, just remember that the mechanical department coordinates the MNP program for the Indian Railways. Can you again explain production of springs in first slide? You see what happens. Unfortunately, the jungle road is banned for you as of now. But when you get a chance to go to the jungle road, you will find that there are 3 bogies which are placed there. And inside the bogie, you will find that we have used large number of springs. So they are basically coil springs which are used for damping of vibrations. Subsequently, I'll show you a slide also where you can see where these springs are placed. And these springs are provided for damping of oscillations primarily, so that the vibration from the superstructure and from the track get dampened. And we manufacture these springs in-house at a rail spring Karkhana, Gwalior. So there is a coiling machine there. There would be a induction machine there, induction heaters and coiling machine, and you coil those springs. And these springs, once they come out, they need to be tested and various activities are done at rail spring Karkhana, Gwalior, SIDHU. Then plant buyback agreement for procurement of wagons. You see what happens when we place an order for wagons to a private industry, let it be Texmaco. So we will tell them that we will give you the steel for the manufacture of the wagon. The wagon body is kind of a cotton steel which is used. So we'll tell them that we'll give you cotton steel and we'll give you the plates to manufacture the underframe, and we'll give you something called a bogie and the wheel sets. Once you go ahead, you will appreciate what is a bogie and a wheel set. So we give them these components because it is not readily available in the market. The private manufacturer, after taking these components from us, is basically fabricating the wagon. So he is using a specific kind of an electrode, and he is using the designs which have been given by Indian Railways, and he will fabricate that wagon and give it back to Indian Railways, and Indian Railways will pay him some amount for that. So Indian Railways has placed an order per wagon of 20 lakhs, assuming. So Indian Railways will say that I'll give you the steel, I'll give you these free supply items of wheel sets, bogies, and you manufacture this, fabricate this, I will pay you 20 lakhs and you give back this wagon to me. So this is the arrangement, how the wagon order is done. How LHB coaches are advanced with respect to ICF coaches? Yes, this I will cover in the coaching class. I told you I will be covering these. I'll cover diesel loco, I'll cover wagon, I'll cover coach, I'll cover workshop. So there are 4 or 5 classes. In one of these classes where I'm taking for coaching stock, I'll address this question: how LHB coaches are advanced with respect to ICF coaches. Sir, since traction and rolling stock are down to the one department, is there any chance that mechanical officers get posted in electric loco shed? You see, earlier what happened, if you go back into the history of Indian Railways, the diesel sheds used to have one electrical officer in assistant scale, and the and the electric loco sheds used to have a mechanical officer in assistant scale. There is a lot of similarity in an electric locomotive and a diesel locomotive. The only difference is diesel locomotive produces its own current, whereas the electrical locomotive is taking the current from the catenary. Now, with the thinking where we have started amalgamating the electrical and the mechanical department, these sheds are also getting amalgamated. So you will find that the diesel sheds have started maintaining the electrical locomotives also, and correspondingly, the electrical loco sheds have also started getting inducted with diesel locomotives. So this, because when you will come to the basic design, there is hardly any difference, except the fact that the electrical locomotive is taking the current from the catenary, diesel locomotive manufactures its own current, and even if there is a change, the change is only in the superstructure side. Below the underframe, where the bogie is there or the motors are there, the concepts are more or less similar. So yes, mechanical officers would be getting posted in electrical loco sheds and vice versa. Traction loco is basically an electrical loco. You can call it a traction loco or an electric loco. Doesn't manufacture. Why doesn't IR manufacture dual load mode locomotives completely instead of completely switching to electrical locomotives? Yes, IR had done an experiment around a year back where we tried to convert our diesel locomotives into dual mode locomotives, and the traction correspondingly the electrical locomotives were also converted to diesel locomotives. Two locomotives of this design were made. But please understand that the locomotive is a moving space and there is a specific length of the underframe where you can accommodate it. So, just a second. वहीं पर है number. So there is a moving space and there is a limited space of the chassis which is available to you. When we started converting the diesel locomotive into a dual mode locomotive, we, along with the power pack or the engine which was available on the diesel locomotive, we also fitted one electric transformer so that it can downgrade the 25 kV supply, which is there in the electric locomotive. So there is a space limitation on the chassis length which is available with me. So this experiment was done on two locomotives, and whenever you are introducing a new rolling stock onto the track, you're supposed to take permission from a gentleman called CCRS, or Chief Commissioner of Railway Safety. So this design was offered to Chief Commissioner of Railway Safety. He did pass it with some restrictions, and that is why it was thought that it is not very advisable to go in for conversion of the present diesel into an electric locomotive. The second analogy of this can be that I should buy a dual mode locomotive or I should try to develop a dual mode locomotive from clean slate design. But then when my thinking is that I have to remove diesels altogether because electric is considered to be more environment friendly as compared to diesel. So there is no logic I should continue with the diesel locomotive. And that is why Railways has taken a philosophy or a thinking that we'll go in for 100% electric and we'll manufacture only electrical locomotives. Okay. So now I'll move ahead. Now, what are the various kinds of diesel locomotives which are available on the circuit? You should try to appreciate. So this is a steam locomotive. Indian Railways still has a shed at Rewari where we maintain around 40 to 42 steam locomotives, and this is one of those. These locomotives are used for inaugural runs or basically tourism sector or in movies. Like this loco you would have seen running next to Salman Khan in Sultan where he is practicing for becoming a wrestler. So these locomotives are more now for, you can say, enthusiasts and for tourism and for tourism purposes primarily. They are not used for any mainline operations, but we still manage around 42 of these locomotives at a place called Rewari. There is a shed in Rewari. This is an Alco locomotive. I told you that there is a design which we took in 1960s. We took it from American Locomotive Works and the acronym Alco got stuck up with it. So before I move ahead, you should appreciate this locomotive. Around 3,000 diesels of this kind are there on the system. Now, in this locomotive, first thing you should know is that this locomotive has capability to work in both the directions. So it can travel in the right hand side also, it can travel in the left hand side also. In the right hand corner, you will find that there is a small cab. So this is the place where the driver is sitting and he is operating the locomotive. So there is a control stand. There would be a control stand here on which he would be sitting and operating the locomotive. All of you would be asked to travel on these locomotives at some span of time. And when you are traveling on the locomotive, that activity is called foot plating. And how that term came is, you see, this is a footboard. You will find that there are handrails or support rails which are provided here. And there are checkered footboards here underneath which the batteries are placed. So, with from this, the term came that when you travel on the locomotive, it is called foot plating, and your DRM will say that you have to go and foot plate the locomotive just to see whether the system there are some lacunas in the system, or to check the promptness of the staff who's operating the network. It may be the driver, it may be the guard who's exchanging the signal, or he may ask you to footplate on the locomotive to see the visibility of the signals. So all of you would be getting a chance to footplate on the locomotives, and it is suggested that during your foundation you should try to footplate once, either on a diesel locomotive or on a traction locomotive, to get a feel as to what happens. Now, in this locomotive, I told you that there is a driver who is sitting on the right hand side. This side is called the short hood, and the opposite end where there is a headlight which you can see is called the long hood. So when the locomotive is moving in the left direction, it is called long hood traveling. When it is moving in the right direction, it is called short hood traveling. So now if the driver is sitting in the cab here, when he's traveling in the short route direction, his visibility is 100%. He can see the signals very comfortably. And the trains are run over the Indian Railway network based on the aspect of the signal. The aspect may be red, green, or amber. And the driver will control the speed of the train based on the aspect of the signal. The emergency braking distance of a locomotive is approximately 800 meters when he's running at 100 kmph. So the drivers are able to spot the signals at a distance of 1 to 1.5 kilometers. And that is why the visibility becomes very, very important. So when he's traveling in the shorter direction, his visibility is perfectly all right. When he's traveling in the longer direction, his visibility is slightly impaired, but still, in this design of the locomotive, he is still comfortably able to spot the signals, because this locomotive has the capability to work only up to 120 kmph. So this is the Alco family locomotive, and when I say Alco family, that means I took one design of a locomotive and then gave large number of variants of that design. Because I was owning the design, I could tweak the designs, and I kept on upgrading the designs. I kept on changing some components in the locomotive. So the locomotive which I took initially was a 2600 horsepower locomotive. Now the bulk locomotives which are working over the Indian Railways from the Alco family is a 3100 horsepower locomotive. So I took 2600 horsepower to 3100 horsepower from the same envelope, and the predominantly now 3100 is stabilized. So in Alco locomotive family, you will find 3100 HP locomotives which are working on the system. So this is an Alco locomotive. Similarly, this is a HHP locomotive or a General Motor locomotive. You will find this also has a short hood here where the driver is sitting, and there is a long hood here where when he's working in the long hood direction, he is working towards the left. When he's working in the short hood direction, he's working towards the right. Now, in this design, there is a component which is fitted here, which sometimes impairs the visibility of the driver. This locomotive is capable to touch 160 kmph, and because in mail and express trains we were finding difficulty, the driver was finding difficulty in spotting the signals, we created a design of the locomotive where we copied this cab at the other end also. So there are some mail and express general motor locomotives where you will find that there is a cab at both ends, and that locomotive is called a dual cab locomotive. Electrical locomotives conventionally always had cabs at both ends, but the diesel locomotives in the Alco design have cabs at one end only. In the high horsepower design, some locomotives are with a single cab and some locomotives are with a dual cab. So there are two cabs at both ends. You will also see that I have written some acronyms here, which is a WDP4, which we'll see what is later on, and you will find that there is a unique number 20011. So this loco number is 20011, and underneath here, if you see, they will write that it is owned by which shed. So every loco is numbered with a unique number, and it is owned by a specific shed. So say, let us take an example that there's a shed at Sabarmati and this locomotive is homed at Sabarmati shed. So Sabarmati shed will say that in the 150 loco holding which I am having, 20011 is also a part of that holding, and he would write here in Saigna Sabarmati diesel shed Western Railway, so that when the loco comes out, anybody can say that this loco is owned by which shed. This is the high horsepower locomotive. This is the General Electric locomotive. GE has set up two sheds, one shed at Rosa and the second shed at Saranpur. So this is a General Electric locomotive, which is a by agreement of Indian Railways. It's a four-stroke diesel, and they have also been given a unique number, which is they have also been given a unique identification WDG4G and with a number series. So this is a 4500 horsepower locomotive. This is a 6000 horsepower locomotive, and this is the series which is being supplied by the General Electric. So here you see it is written that it is homed at Rosa, and this is the unique number of the locomotive. Now, why uniqueness is required? So that you can identify which loco is behaving properly, which loco is misbehaving, what is the cost of maintenance activity of that locomotive, what is the history of the locomotive. So these are the reasons why you need a unique identification to each locomotive. Now, these are the acronyms which I told you are the digits. So when I say it is a WDG4, W indicates that it's a broad gauge locomotive. D would indicate the traction mode. So if it would have been an electrical locomotive, the number would have been WAG4. So A would indicate that it is an AC locomotive, and D indicates it's a diesel locomotive. And G would indicate what is the specific service to which the locomotive has been designed for. So you have locomotives called WDG, you have WDP, you have WDM, and you have WDS also. Now appreciate that when you are running a train, the characteristics of the locomotive which are available to haul a specific kind of a train should be different. If it is a mail and express train, the locomotive should be capable to accelerate faster. It should be able to attain higher speeds faster. Whereas if it is a goods locomotive, it should have the capability to haul higher loads. It should have something called capability of higher starting torque. That means it should be able to haul higher loads. In goods, the speed does not become vital, whereas in mail and express, the speed becomes vital. And we can do this by tweaking the design of some gears in the underframe. So there are locomotives which have been designed specifically to a specific service. You have a passenger, a locomotive designed for mail and express only. You would have WDP written there. You have a locomotive designed for a good service. You would have a WDG written there. There are some designs where you will find a WDM3D is written there. So there M indicates it's a mixed service locomotive. That means it can go in mail and express also. It can go into the goods service also. And there are some locomotives which are designed only for shunting operations. Now, when you go to stations or you go to yards where the trains are formed, you will find that there are some locomotives which are pulling the empty rake and putting it in the yard, or they are cutting, say, the fifth coach, putting in another new coach in that place. This activity is called, and some locos have been designed only for specifically shunting activities. Further, the last three numerical digits indicate the horsepower. So assuming I have written here as WDM3A or I've written it here as WDG3A in the ALCO family, so it will indicate it's a broad gauge diesel locomotive, mixed service, 3100 horsepower locomotive. Every ABCD adds 100 horsepower. Predominantly, I have WDG3A. It means I have a broad gauge diesel goods 3100 horsepower locomotive. It indicates it's a broad gauge diesel goods. Here 4500. Why it was written as 4 when the HHP and I made it into a 4500 horsepower locomotive. So all WDG4s are 4500 horsepower locomotives. So if I write here the acronym, if you go back to this photograph, if we go back and we write here WDP4, it indicates it's a broad gauge diesel passenger. That means mail and express 4500 horsepower locomotive. And if I write it as WDP4D, here D indicates it's a dual cab locomotive. So please remember 3 or 4 designs which are very important. One is WDG3A, second is WDG4, third is WDP4 and WDP4D. So these are some variants and some acronyms which are provided to identify these logos. And when you will sit in meetings or when you will talk to your counterparts, they will be speaking to you in these acronyms only. Now, this is the evolution as to what have been the various designs. So this WDM2 was the initial design in 1960s, which I took from the American Locomotive Works, and up to WDM3D, I upgraded the design. So the whole of the left side and the topmost right is the ALCO family, and from the WDG, I started the HHP family. In the HHP family, the strongest locomotive which I am having is a WDG5 locomotive or a broad gauge diesel goods 5500 horsepower locomotive. I manufactured this and it is running over the system. So this is a brief evolution of the diesel locomotive family. Now, in the headquarters, this is an example of South Central Railway as to how the diesel locomotives are maintained and what a diesel locomotive is. Just quickly appreciate this. I told you that there is a CMP diesel who's there in the headquarters, and there are 5 sheds in this zone. So you have a shed at Gutti, which is GY. You have a shed at Guntakal, you have a shed at Kazipet, you have a shed at Molali, you have a shed at Vijayawada. So there are 5 diesel sheds which are there in 650 diesel locomotives, and these 650 diesel locomotives are distributed across these 5 sheds. So say Gutti would be having 150 to 200 locomotives, Kuntikal would be homing another 100, 150, Kazipet would be homing some types of locomotives, Molali and Vijayawada. So individually, senior DMA diesel Gutti is responsible for providing maintenance activities to the 150 diesel locomotives which are homed in his shed. So he is responsible if any locomotive of his fails or the locomotive comes late for train operations, then senior DMA diesel Gutti would be hauled up. And for all these 5 gentlemen, CMP diesel is the man who's coordinating the activities at the headquarters level. Assuming he needs to take a decision that I want to reduce the number of locomotives in Gutti and increase the number of locomotives in Kazipet, then the CMP diesel at the headquarters will decide that Gutti locos should come to Kazipet, or CMP diesel will decide that Gutti, you are now, till now you were maintaining the diesel locomotives, you should start maintaining the electrical locomotives also. And CMP diesel will tell this gentleman that you should develop the competence to start homing electrical locomotives and start maintaining them. So that is how the CMP diesel would be coordinating these activities. Just as an example, if you see the Gutti line, which is the second row only, this shed is homing around 193 locomotives. So he is having 10 of one kind, 23 of another kind, 23 of another kind, 102 of the WDG4 kind. So predominantly it's a goods locomotive shed, and it is giving the locomotives for goods operations or freight operations. And Why this was located at Gutti is because Gutti is at a cross junction where there is heavy iron ore movement and coal movement. So we want that the locomotive should be available for traffic service very quickly. We should not waste time, and that is why a shed was created at Gutti, which is maintaining and providing service to these locomotives, these 102 goods locomotives, which are provided for the freight operations in that sector. So it's just an example. This is, every shed would have its own kind, and this is how the locomotives are distributed across a zone. So I told you that this zone is having around 600 diesels, and this is how the zone has divided the diesels amongst its 5 sheds, and each shed is maintaining those diesels on a daily basis. Now, coming back to how the transmitted in a diesel locomotive, you should appreciate this. A diesel engine which is provided in crankshaft, they will rotate. The crankshaft gets to a node that rotate and it will rotate. You have works when the pistons go up and down. Mechanical energy gets converted to electrical energy. This electrical energy through cables goes to the motors which are placed underneath the locomotive. When the motors move or they rotate the wheels of the locomotive and it gets converted to kinetic energy or motion. Let us take an example here. These are simple laws of physics or Newton's law. The locomotive is producing some power. So on the right hand side, it is producing some tractive effort. Now, tractive effort is dependent upon the horsepower of the locomotive, the weight of the locomotive, and the addition factor of the locomotive. It is producing some tractive effort, or it is a force, the propelling force on the right hand side, which is being balanced by some resistances on the left hand side. So there are a large number of resistances which come, which has to be overcome by this tractive effort. Till the time the right hand side is more than the left hand side, that means till the time the tractive effort is more than the resistance, the locomotive will accelerate. You will keep on getting acceleration. But a stage comes where the tractive effort balances the resistance on the left hand side. At that stage, there is no acceleration and there is constant velocity. And that is called the balancing speed. So Indian Railways always wanted a higher balancing speed. Why? Because when you assume a section, there are 2 stations which are 15 kilometers apart, and you start a train from station A and it has to reach to station B. Once it reaches station B, then only you can push in another train from station A. So you want that between station A and station B, the section is cleared by the train as fast as possible. So that is only possible if it is able to achieve the balancing speed quickly. And for that, you need higher acceleration potential and a higher balancing speed. And that is why you have gone in for saying that we want higher horsepower locomotives. The benefit of higher horsepower locomotive is it can accelerate faster, it can achieve this balancing speed faster, and it can clear the section faster. So that once you clear the section faster, you can pump in another train behind this train. Now, these are the various resistances which come into play from the initial start. So first is the rolling resistance. There's a Davis equation. It is a function of the weight of what is the rolling stock behind of a say coach or the wagon. What is the frictional bearing resistance? There is something called flange resistance. Now, if you go back to your toy train times, The locomotive wheel is having a flange. That flange is something which is helping the wheel to get guided on the rail surface. So when it starts from scratch, the flange has something called a flange resistance because it has to rub against the rail head. Wind resistance, especially after 110 kmph, the wind resistance plays a very, very vital role. And that is why you will find that all high speed trains have a aerodynamic profile. It may be an aeroplane, it may be a bullet train. They have aerodynamic profile so that the frontal wind impact is reduced. Even the diesel locomotives have an aerodynamic profile in the sense that in the front you will find that they will have curved edges. Curvature resistance. Indian railway track is not straight. It is in curves. So you will find that there is a 3-degree curve or a 4-degree curve. It is not a straight track. And when you are starting the train on a curve, it gives you some curve resistance because the flange of the wheel would be biting into the rail head. And the next resistance is grade resistance. Now, grade is there is up gradient and there is down gradient. Again, Indian Railway track is not straight and is not level. So, if you have to start a train on a grade, it gives you that component of cos theta and sin theta inside the weight parameters, and it gives you something called the grade resistance. So, these are all parts of the resistances which the tractive effort has to overcome. Until the time the tractive effort is more than the forces or the resistances which are coming in the back, you will get acceleration. And when the forces balance, then the train speed does not change. It stabilizes at a constant speed, and it is called balancing speed. I'll explain flange resistance later on. I will show you a wheel set, then you will appreciate it. Okay. All MEMUs, DMUs work on the same principle. MEMUs, DEMUs, the difference is that they are distributed power train sets. As of now, just keep in mind that MEMU, DMUs are distributed power train sets, and we'll see what the distributed power and localized power means later on. Keep this in mind, keep this question in mind, and I'll cover it later as to what is the difference between a MEMU, DMU, and a conventional train. Okay. Now, this is what the diesel locomotive looks like, a broad stretch. So you will find that there is a cab in which the driver is sitting here. In the right hand corner, you will see in green, there is a control stand by which he is operating the locomotive. You will find in green, in dark green, there is a diesel engine. So the Alco locomotive or the HHP locomotive also is a 16 cylinder V engine. That means there are 16 power assemblies. Your car has 4. It's an IC engine. It is similar to what is there in a car or it is there in a scooter or anywhere. Only thing is the sizes are different because your car is of 8 HP or 10 HP. Here it is 4,000 horsepower. So there's a diesel engine here, and you will find that the coolant which we are using in the diesel engine is treated water, and you need to cool the coolant also. And that is why we have on the left hand side, you will find that we have huge radiators in which the coolant gets goes in for heat exchange, and there are radiator fans on top of the locomotive which are providing forced draft. So sometimes whenever you cross foot over bridges, you will find that there are radiator fans on top of the locomotives. So they are basically providing a forced draft for cooling of the coolant in the radiator panels. You will find that I have written there is a sandbox here. You see what happens, the locomotive carries its own sand. As I told you that the tractive effort is dependent upon the adhesion. So during the rains, what happens because the railhead becomes wet, the wheel has a tendency to slip on top of the railhead and you need to increase the adhesion. So you start dropping sand between the wheel and the rail. And that is why you carry your own sand. Just a second. Your class chal raha hai. Okay. Now, this is called the this portion is called the superstructure. Okay, so this is the superstructure. This center rectangle is called the underframe, or it is the chassis of the locomotive on which the superstructure is created. When you go down, you will find that I have written something called truck frame. So there are two truck frames. So these are bogies. Now, these bogies are free. That means they are not, unlike a road vehicle, they are not directly coupled to the underframe, whereas they are connected with the help of a center pivot pin. So there is a pin which goes from the underframe to these bogies, because these bogies have to have flexibility to execute curves, and they should have rotational flexibility. That is why they are connected with the help of pins, center pivot pins, with this undercarriage. And each bogie you will find, I have shown three wheel sets. So there are three wheels in this side, there would be three on the opposite side. Now this is a bogie with three wheel sets. On this bogie, there is a traction motor. On each wheel set, there would be a traction motor which is provided. So when you pump in fuel here in the diesel engine, this will rotate, it will produce mechanical work. It is connected directly to this alternator. This alternator will rotate, produce current, and this current through cables comes down to these traction motors here. The traction motor rotates, and the traction motor is connected to the wheel set with the help of gears. So when the traction motor rotates, these wheels also rotate. So this is how the locomotive moves. Now, each locomotive carries its own fuel. So there is a fuel tank. The fuel tank has capacity for around 5,000 liters of diesel in it, and broadly 5 liters per kilometer is consumed. So once filled, the locomotive gives you a range of around 1,000 kilometers. Also, the underframe is provided with air reservoirs. You see, in the superstructure, have I shown you a compressor somewhere here? Yes, in the blue, I have shown you a compressor here. This compressor is producing large amount of air. This air is getting stored in the air reservoirs. The braking system in train operations is pneumatics. So the whole train brakes on the pneumatic brake system. So you need large amount of air. So the locomotive has pneumatic brakes, the coaching stock has pneumatic brakes, the wagon stock has pneumatic brakes. The locomotive carries this air in these reservoirs and pumps it into the whole of the train formation. And whenever the braking happens, this air gets exhausted into the atmosphere, and again the compressor will rebuild the air which is there in these reservoirs, and this air gets transmitted to the whole train used for braking operations. Now, this is another look. As I told you, this is called the long hood. This is called the short hood. And why in this portion is where the engine is kept. And because it is a single hood, hood is nothing but a cover. And because it is long, that is why this is called long hood. This is what is called the short hood direction. These are the bogies or the truck frames. This is the reservoir. And if you, I think this center pivot pin is not visible, forget it. And this projection is called the buffers, or these are the couplers. So these are center buffer couplers through which the locomotive gets connected with the coaching or the wagon stock in the rear. The another look. Now on the right hand side, you can see that 29 is the place on which the driver is sitting when he's traveling in the shorthood direction. This is his control stand. He will sit on 29 again above when he's traveling in the long hood direction, and this is the separate control stand for this. This is an engine which is a 16-cylinder engine. So this is a traction generator on an alternator. Turbo is a component which provides compressed air just to increase the power of the locomotive. There's a compressor, there is no expressor anymore because there is no vacuum based system. So there's a compressor here. These are those huge radiator fans which are providing you the forced draft of air against the radiator panels for cooling of the water or the coolant. So this is what the locomotive looks like. Now here, this is called conicity. Then this is a wheel set, and this is the design of a wheel set. There are two wheels, and there is an axle which is coupled, and it is moving on the rails. Okay, so this is moving on the rails, and on this wheel set, the wheel set movement on the track is never straight, it is sinusoidal. That means the wheel is a floating wheel and follows a sine wave pattern while it is traveling on the track. Now, why this conicity is provided? This conicity is a 1 in 20 profile which is provided on the top of the wheel. Assume that this wheel set has to execute a right hand curve. Okay, now two wheels are coupled on a single axle and both the wheels are rotating at 1000 rpm. The outer wheel, that is the left wheel, has to execute a bigger distance as compared to the inner wheel. Okay, when they are on the same axle rotating at the same rpm, and the track on the outer track would have a higher radius as compared to the inner track, the outer wheel has to execute a larger distance as compared to the inner wheel. So what will happen in that stage? This conicity permits you that the outer wheel will go to the maximum diameter, the inner wheel will go to the lower diameter. If it was doing a left hand curve, then the right hand side wheel would go to the maximum diameter, the left hand wheel would go to the lowest diameter, because they have to execute different distances, but because they are coupled on the same wheel set, they are rotating at the same RPM. Now, this is called the wheel profile, and all the rolling stock, the wheel profile is monitored and maintained. So, you do machining or you do turning to ensure that the wheel profile is maintained. And there is a flange. Now, this flange is what is rubbing onto this rail head every time. If you again remember the your toys, you would have all played with trains. This is the flange which is getting guided by this rail. So when at the time of start, assuming this flange is touching with this rail head, the wheel has rested in this position, or you are on a curve. If on a curve, on a right hand curve, you will find that the outermost wheel flange would be again rubbing against the rail head, and you have to start a train at this position. Then this flange will start rubbing against this rail head, and we will give you something called flange resistance. Or assuming the wheel set is taken in such a position that it is slightly twisted, and in that case, again, the left hand wheel front area of the flange would touch the railhead. That is called positive angle of positive. That is called positive angularity. Okay, so the wheel would be touching the railhead from the front. Okay, correspondingly, the left hand wheel, the rear portion would be touching the railhead. So in this circumstance, when you are starting a train, you are getting flange resistance. Okay, so this is important. You should understand that coning, why coning is done on wheel treads and why coning is provided in all the rolling stock, because you have to execute curves, and that is why you give floating axles. And the wheels being on the same wheel set have to execute different distances when they are executing the curve, and that is why conicity is provided. I think I have explained flange resistance. Now the question is, what are the exact difference in duties discharged by ADME, DME, and CNDM? Okay. So let us take an example of a diesel shed. Uh, I am South Central man, so I'll take an example of Kazipet diesel shed. There's a senior DME diesel in Kazipet who is sitting in Kazipet shed, who is in charge. He is supported by one DME, and he would be having two AMEs. He would be having one ACOS. He would be having one ACMT. ACOS is the storesman who is helping him in procurement of material. ACMT is the chemist and the metallurgist who is helping him with the testing of the lubes and the oils which are coming. So now what happens? This gentleman is having 200 diesels with him. Each diesel costs around 7 crores from the Alco family and 14 crores from the HHP family. He is having a shed which is spread out in 25 hectares of land. He is having 1,000 people with him. And the senior DME has to manage this day in, day out. 24 hours he has to turn out the locos for service. Locos are coming in for maintenance, locos are going out from maintenance. So he has to execute running maintenance, he has to execute heavy maintenance. So he will say, look, one AME you will look after the running maintenance, second AME you will look after the heavy maintenance, DME you will look after the movement to ensure that the locomotives go in for service timely so that no train is hit. So this is the difference. The AME is the bottommost level. He is the first in the shed. He is ragged by everybody. And it is not an AME also, it can be an ACOS, it can be an ASC, it can be anybody. When you get posted in the assistant level, you are the first of the organization. Just remember that. And you are a direct in charge for say 300 people. And if you are an AN, a section of 150 kilometers. Now in that 150 kilometers, those 300 people are asking you every day. And if anything happens in that 150 kilometers, your head is on the hacker range altogether. And your senior DN coordination would be having 1500 kilometers with him, and he would be having 6 AENs in one direction, one DN to coordinate those 6 AENs. Similarly, here 3 AMEs looking after different activities, or 2 AMEs, one DME looking after one activity, and senior DME to coordinate with huge number of more activities, ensuring that the material is there, ensuring that the people are there, ensuring that the locomotive comes to time, ensuring why the locomotive has failed to do failure analysis, explain, take corrective action, take preventive action. So don't worry, you will not find time to get bored in Indian Railways. The happiest time is probation, when you have time. Once you get posted, you will have no time. Okay, so these are some of the duties which are different in assistant scale or senior scale or JA grade. Are these compressors reciprocating type or centrifugal? These are reciprocating type compressors. There are 3 pistons, and we have pistons which are moving. So they are provided to us by KPC and LG. These are 2 companies who are the suppliers of these locomotive compressors for us. Okay, so I'll move ahead. This is what a bogie looks like, and this is now. Uh, give 2-3 minutes here. So there are 3 wheel sets, and there was a question, what are the springs? So these are helical springs. You see, these are manufactured in Rail Spring Karkhana, and it's a nest of springs. So there is an outer coil spring, there is an inner coil spring, and these springs are placed here. This is part of the suspension system, and this is a basically tri-mount bogie. So you have a center pivot here. This center pivot is the portion by which this bogie is getting connected to the underframe. And besides getting connected to the underframe, this center pivot also carries 60% weight of the locomotive. And there are 2 side bearers who share another 40%. So under a locomotive, there are 2 bogies, one in the front and one in the rear. There are some. So how does the weight come? The weight comes on this center pivot, weight comes on this bogie frame. From the bogie frame, it comes to this equalizing beams. From the equalizing beams comes to this axle box. From the axle box comes to this wheel. From the wheel goes down to the ground. So this is how the weight gets transmitted. These traction motors would have current. These are suspended traction motors on the bogie frame, and the when the generator is producing current or the alternator is producing current, with the help of cable, the current comes to these traction motors. These traction motors have a small pinion which is coupled to this. There's a gear, there's a bevel gear which is provided on this wheel set, and these 2 gears mesh with each other. When the traction motor rotates, this wheel rotates. So this is a tri-mount bogie. Also, there is a small classification which is from the American Association of Railroad. This bogie is called a CO bogie. So what does CO indicate? C indicates the number of axles which are provided. So in this bogie, there are 3 wheel sets which are provided. So you identify it as C, and each wheel set is independently driven. That means you have motors on each wheel set that is identified by O. And because there are 2 bogies available under one locomotive, it is called COCO bogie. Understood. So if there were four wheel sets in this bogie, if there were two wheel sets in this bogie in place of three, it would have been called as BO, and BO for the second bogie. So you have a Bobo bogie loco, you have a Coco bogie loco. Now this classification is used both in diesel locomotives and in electrical locomotives. You have Bobo bogies, you have Coco bogies also. The function of center pivot pin is that center pivot pin is the place at which the superstructure is resting through the under frame. So at this location the under frame is connected. Now this bogie has to be coupled with the locomotive also. You see, the bogie cannot be completely free, because if you have to locate the bogie underneath the undercarriage on under the under frame also. So center pivot is the place at which you locate. So you basically, there would be a pivot pin which is coming out from the undercarriage and it is going inside this bogie portion where it is getting connected. Plus it is also doing weight transmission. So here there would be a pin which is going inside, so that this bogie gets located, and also the undercarriage or the superstructure would be resting here. So the weight gets transmitted onto the bogie. These are some major components on the locomotive. This you can skip. Now, this is American Classification Association of American Railroads, which I've already told you what a Coco or a Bobo is. Now, these are the various technologies of transmission of power which are there, and you can see only the last line. The above two are only historical. So you have a diesel engine which is producing current. It can have a generator, it can have an alternator, and you have traction motors. It's a diesel electric locomotive. That means it is eating diesel and producing electricity. So earlier, the family had DC DC. That means we were producing DC, we were consuming DC. Then we had AC DC. That means we were producing AC. We replaced the generator with an alternator, but the motors were DC in the underframe. And subsequently, in the end, which is the technology now, it is AC AC. That means we are producing alternating current, we have alternators, and we have AC motors underneath the locomotive to run the locomotive. AC motors are conventionally better than the DC motors from the maintenance aspect and the reliability aspect also. This is engine utilization. This is just an example, but this is a parameter which is monitored as to how much is a diesel engine, a diesel locomotive is approximately earning per day. So a goods loco earns around 380 kilometers odd, and a passenger locomotive earns around 600 kilometers odd. This figure keeps on changing on an annual basis with the lowering of the numbers of diesels which are available and increasing the number of traction locomotives. You will find that this figure has gone down, and you pick up the statistical manual which is published by Indian Railways every month. You can see what are the latest figures in those of utilization as of now. Now, this is just an example. I had told you that the locomotive comes to a shed for specific schedules. So this is some identification of schedules. So you have trip schedule, you have M2 is 60 days, M4 is quarterly or 4 months. We call it quarterly. Then you have M12, M24, M48. There's the number of months, and up to 4 yearly schedules. You do it in the home shed. So if the locomotive is homed at Kazipet, Kazipet shed would be doing maintenance in this home shed. And there is something called periodic overhauling, which is at an interval of 8 years or 10 lakh kilometers, whichever is earlier. But broadly, it is 8 years where it goes to a workshop and rebuilding, where after 18 years, the locomotive used to go to diesel modernization works, Patiala. So now let us take an example of a locomotive, and HHP locomotive which is homed at Kazipet shed. So it would be visiting Kazipet shed continuously after 40 days for one schedule, again after another 60 days for another schedule, again after 4 months for a schedule, and so on. So up to M48, whatever schedules are required to be done, Kazipet shed would do it. But after M48, if any schedule is required at, say, the age of POH, Then Kazipet shed will send this locomotive to an associated workshop where higher level of activity is done. So that is periodic overhauling. Understand this concept slightly because it is common between locomotives and coaches. So once you understand it here, it becomes easier to understand there. This is how we have gone in for power upgradation and specific fuel consumption. There is just a graph just to make you appreciate that we have always been working on the reduction of the diesel consumption. There's a parameter called specific fuel consumption, and we have gone in for fuel efficiencies. And this is what is more important. You see what happens whenever the locomotive is coming to the shed for maintenance activity, it is downtime. You're not able to use that asset. It is not available for traffic use. So the thinking has always been that the locomotive should remain outside the shed premises and it should be available for traffic use always. So we have worked towards increase in periodicity of scheduling. So you will find that we started calling the locomotives initially after 7 days. Now we call the locomotive after 30 to 40 days. Second benefit of advance of this increase in periodicity is that the lesser you touch, if you remember the bathtub curve of reliability, which you must have read, whenever you are paying attention or you are touching a component every time, you will take it to the left extremity where the chances of failures increase. So you want that the person touches the component as less as possible. And that is why we try to increase the periodicity of maintenance. Home shed, I told you that home shed is responsible for maintenance of activities of the locomotives owned by it. So he has to stock all kinds of spares. Locomotive has 4,000 components and he's supported with something called unit exchange. So a shed keeps on monitoring these unit exchanges. So what will happen if assuming the cylinder, if the cylinder head in the compressor has failed, rather than attending the cylinder head at in situ, if he has to turn out the locomotive faster, he will replace the compressor with another compressor, and that compressor is called a unit exchange spare, which is maintained in his shed. So every shed will have some unit exchange spares. These are the main systems in a diesel locomotive. Again, something similar to the automobile technology. So you will have fuel oil system, you will have lubricating oil system, you would have a cooling water system or a coolant system, and you will have a charge air system for the intake and the exhaust part. Now, the question is M stands for, okay, that M stands for months. Okay. Once the quarter life of wagons, wheels, axles gets over, is it reused? And if so, how it is done? You see what happens. Basically, the wheels and axles are remelted. Assuming the wheel, whenever a wheel is forged or it is cast, it comes with a dia of 900 meters. It's only an example. And I told you that we maintain a profile. Over a time period of time, the profile gets damaged. You turn the wheel, you reduce the diameter from 900 to say 830 by turning it. And the minimum diameter which is permitted is say 800 meters. I do 2-3 turnings and I find that I reach the minimum diameter of the wheel. I will withdraw that wheel and the axle set from the system and I will send it to rail wheel factory Yalanka. What they'll do, they will remelt it, they will melt it in their blast furnaces and recast new wheels. Okay. Whereas other scrap, if there is more scrap which cannot be melted, then it is sold as a scrap. It is something like ship breaking in Alang, which happens. We also sell those components. We sell them through the stores department as lots. Sometimes we sell our old locomotives to private customers. The steel plants, the collieries, they have all set up independent merry-go-round systems where they carry coal in their own collieries. So they'll buy old locos from us and they will hire some retired employees of railways only. With the help of these old locomotives, they are able to run the show for another 10-15 years. Why? Because they run the locomotives at a speed of 15 to 20 kmph. They don't need an optimum performance of the locomotives, so they use it there. Sometimes the locomotives have become overaged, but they are still good. So what we'll do is we'll use them in inferior services, carrying ballast trains for construction activity or shunting operations on stations. So either we sell the locomotive or we condemn the locomotive and sell it. Also, what happens in the sheds, you will find that when the locomotive is coming towards its end age, we retrieve majority of the components and use them as spares in my regular maintenance. So what I'm basically selling is also left out with a shell only. So that shell gets sold off as scrap to the market. Okay, so it is 11. I end here. I was supposed to finish this presentation in this class, but I'll continue from here at 11:45. So we'll meet in S3, S4. And if you have any further queries, you can ask me then. So you can enjoy your break for 45 minutes. We meet at 11:45. Any other question which I can address now? Okay, so there is no further question. We meet at 11:45. Okay, I'm logging off now and I'll log in at 11.